The positive prompt is a text of things that we want to see. Ideally, we want to see them. You never know because these models are not perfect. But ideally, what you write in the positive prompt, which is the clip text encode, which goes from the node checkpoint, the text encode, and then from here it goes into the K sampler, into the positive input. And then we have the negative prompt, which are things that ideally we don't want to see. So the most common use case for this is, for example, if you try to make something a bit more commercial, then for sure in your negative text prompt, apart from the text and watermark, includes things like nudity, not explicit things that you don't want to see. Even though this is not like, it doesn't work 100%. It's always a bug-based, but you definitely can try to avoid things. So the best example, for example, is you could say, let's create some roses, a couple of roses, and roses usually tend to be red. At least there's always a really high chance of the rose itself being red. Purplish. But now here we could specify we don't want to be red and we don't want to be pink, for example. And then probably now we should get something like the white rose. Yeah. So or another, for example, like a Ferrari. Ferrari, there's so many red ones, so many Ferraris that would write red. But if you just generate one, it's probably going to be a red car. So then you would type in red into negative prompt to avoid it. And for us in architecture, maybe it's more to generate an interior room, and we don't want to have windows. Then you would also try to write windows in the text prompt, and there's like a high chance that you won't have windows in the resulting image. Okay, the thing that you can play around with while I fix the installation here is I want you to play with the first setting, let's say. Or you know what a seed is, no? You don't? Okay, so, great. The seed is, every time we generate an image, we start with a random noise. And this random noise is just like random pixels in this image. And as you all know, there is nothing random in an algorithm. No, because at some point we need a function that calculates this value. There's no way around it. So there are ways of creating the pseudo-randomness. So for example, you create a function, and this function takes also into account the current date, and the current hour and seconds, and takes into account, I don't know, some other random variables, maybe some system specs or stuff like that. And then using all of these things, it creates something that to us appears like a random value. No? And then in order to change it, a lot of times we have the seed where we can then also input like a if for example we don't use the current date and hour, but we have like a random function that is consistent in its output, we can change the seed so that we would always have like a new random value for our noise. And in our case for stable diffusion, what it means is that if we change the seed to fixed, like control after generate, this one is C, and I would type it in the C like, I don't know, 1. And I generate, I get this image here. Just gonna copy this, copy, paste. Then I generate with a seed of 2. I have a new random noise, which gives me a new image. It still contains what I'm looking for, no, but it generated a new version of it because it started with a different noise. Copy, paste, and every seed, I have a new image, even though it has the same prompt. However, if I now reuse the same seed, I have again my seed of 1, which we already used, and I generate the image, I will get the same image that I got when I used seed 1 in the perfect one try ago. No? It's again the same image. If I use seed 3, which we haven't used yet, I should get like a completely new image. That's what seed does. So if you have the same settings and the same models as another person, and you share the script, and you use the same seed, you will get the same result. If you use a different seed, you get a different result. And this is good because sometimes with a seed you can use it in order to test settings, test words. You know, maybe we use the same script, but then we change one word. And if you use the same seed, it's a bit more consistent. Like you can see a bit what this word exactly does. So now I want you to tell me what the steps do, which means you use a fixed seed of whatever number you want, and then you can just, you can just use your, you don't have like your random numbers that you always use.
It's a very random number.
So you use your fixed number, and then generate maybe, let's say, 4 or 5 images. One has a step of 1, step 5, step 10, step 20, and then let's say step 30. And then you tell me what the difference is and what it does, and I check you know. It works.
So just how do you get the image to stay?
Yes. Yeah, so there are 2 ways of saving an image. It will all, like the default script will always also save the file on your desktop. Like every time you generate something, not on desktop, sorry, in a specific folder. So instability matrix, you can just click on the menu, and then it will tell you, I think it's called output folder, probably. And there you should find all the generated images. Else, you can also click on help, open folder, and then outputs folder. And here, every image I have generated is here. If you want to avoid this, because this is filling up your memory and you don't need every single image that you generate, you can also create a new node. And we do this by double-clicking somewhere in the canvas, for example. And then we can also write preview image. And if you type, you can see that it also it highlights you on the left how the component looks like. Now maybe you have 2 or 3 components that are a very similar name and you don't remember exactly what the name was. But this, if you just hover over the different components, you can always see the preview. No? So for us, we need the preview image component. And this one looks exactly like the same image component. It has an input, which wants an image. No? And after the DAE decode, because the case center works in latent space, the DAE decode brings our image into image pixel space. And then we take the image from here into the preview. We can delete the same image if we want to. And now we generate again. We queue it up. It gives us this preview, and this preview is not saving it. It's not saving it anymore in our folder. Now the folder stays empty. If we want to save this image now, we can right-click on the image and click on Save Image. And then we can just save it wherever we want. Or here we can also copy the image, paste the image. Yeah.
What is the resolution of we can change
What do you mean?
the resolution?
The resolution? Oh yeah, that's the next thing. First I want you to tell me what steps does. Alright. So let's generate some images and then explain to you what it does. Yeah. So you will need insert. Yeah.
Ah, I see.
That realism of checkpoints, vision.
How do you keep the old images?
You have to copy the replica, otherwise it copies the same image, the same, I mean the component, same image instead of the image itself.
Okay, so yeah, you go copy it?
Yeah, you otherwise you copy the component.
So you actually have to copy the image from the and then you go copy image and you just paste it? So you just drag and say copy image.
Is it more complicated prompts? Does it take longer for them to load?
No. Like it doesn't matter how long your prompt is. I think there's just like a limit in terms of how many tokens you accept. So if you have a very large prompt, at some point I think honestly I don't know. I think it's like 75 tokens or something. But then it just will not take the whole prompt into regards. The problem that you will face sooner than a too long prompt is that just the prompt adherence at some point is not that great anymore. That means that if your prompt gets too long, there's a high chance that it won't be able to bring everything that you set into the image.
Right.
And this is especially the case, like right now we're using SPXL because it's a bit faster and it works on most of the machines here. And it's like not one of the newest models, so also it gets confused in a way. It doesn't understand like natural language the same way we understand it. So we'll try to generate all the words that are in the text, but sometimes it doesn't know. For example, if you would write that you have a white house and a blue windows and red door and blah blah blah. At some point, it doesn't know which color goes where. We try to bring those colors in, and we try to bring the objects into the image, but maybe not exactly the same way you've specified it. With newer models like Flux, which is also in the download folder, I think, or in the file, no, in the email. In email, you have also the links, but this might not work on all laptops because it needs more VRAM. But there, the images are way more precise. Yeah.
Okay.
I have a question, but it's out of topic. You know how there was this debate of AI stealing images from artists?
Yeah.
Like, if I generate something with Comfy UI, like, can I say it's mine or like that?
Actually, I mean, right now there's like a lot of lawsuits going on exactly about this topic. For example, now I think in the US there has been one case where they have said that the image that you have generated with AI, you don't have the copyright for it. However, if you further modify it, then you do. So it means that I think it was like based on like they made a children's book. Then they had the text and then the images, and the whole thing in itself is copyrighted. However, you can take the images and place them out of context somewhere else, and then these don't have copyright. This is right now how the US law has decided. But I don't know what the law right now in Europe is. It's still a bit unclear. Yeah.
No, because I was thinking if I want to use an image for the blog post.
But if, for example, if you then just apply a tiny bit of Photoshop to it, then it's again yours.
Okay.
That's the thing. It's just if you use a raw image where they don't know exactly how the law is yet. Yeah.
Okay.
Yeah. Hope this helps a bit, but there is no like proper right answer right now. I guess it will take some time and lots of more lawsuits, and then at some point we know. Okay, how are we doing with the steps? Can someone tell me already what they do? How many images have you generated already? 3. Okay. No, then probably there should be already a visible result between those.
So the iteration of removing the noise.
Yeah, exactly.
That's also what it says when you hover.
Yeah, perfect. I know. That's good, really good. No, this is great. Like, it gives a lot of information here already if you just read. But it's also sometimes good to just try the things out to properly visually see what the difference is not. And what the steps does is basically it's how many iterations the algorithm goes over the noisy image and denoises it and removes the noise or changes the pixel values in order for us to see something. There are different kinds of models. Usually I would say everything between 20 to 30 steps makes sense. Everything below 20 steps tends to be a bit weird. No? For example, here we have an image of 30 steps, 10 steps, and this is 20 steps. Like there's a big quality increase. This, however, also depends on the models. A lot of times, if you go on Sillet AI, they will tell you the right settings for these models. So they will say, okay, this one is ideal at 30 steps, and there's also samplers. I'm not sure if we have to touch that topic right now, but there are also different samplers that give like slightly different results. I mean, I can show you here. This one, for example, this is the standard sampler. And then another one that I like to use is this one. And the differences are very, well, that was the wrong one. 1 second. Yeah, so there are tiny differences. Some samplers are a bit more like washed out, I would say. Then other samplers create a bit more details. But these are so minor things that I don't think that you have to think about it right now. We ignore this setting, it doesn't exist. However, what does exist is the CFG scale. The CFG scale is how much the diffusion, like stable diffusion, adheres to your prompt. And honestly, I would also not touch this setting. So there are some models, like the Flux models, which use a CFG scale of 1, and it will just tell you. But basically, I mean, as it says here, the higher the CFG scale is, the closer it forces the algorithm to bring in the stuff that you have described in the prompt, but usually at the cost of quality. So I would not go higher than 10, and I think the default value of 8 is totally fine. Yeah. The next thing that we need to cover is what someone already asked for, and that's the aspect ratio. So that's also like the last bit of our standard or default workflow. There is the empty latent image. And this empty latent image is the size of the random noise that we have initially, no? And this also works in pixels. So here I can specify width and a height. Right now we were using 512 by 512. If you change the width to 1024 to 512, then obviously now we have an image that is twice as large as high or tall. And this also has an impact on the result itself, because I think this has to do with how the algorithms were trained on the input images that it had. So if you generate an image, let's copy this, paste this, that is in portrait. Let's say, for example, you generate an image of a column in a room. Then if we're using a portrait aspect ratio, the full focus will be on the column, because probably a lot of input images that it had were, and of columns, had been taken just like the column itself as a center of the image itself. No? However, if you then use an aspect ratio which is more horizontal, the column might be on one of the sides, and you see way more, like you get more information about the room itself. So when you generate an image, then also be aware of which aspect ratio you pick in order to place the object in the center of you, as a centerpiece of your image, or more to the side. So here also with a skyscraper, I mean, in the image now that we're generating with the skyscraper in the middle, no, with the portrait, the full focus of the image is now just on the skyscraper itself. However, here on the image on the right, where we're working more in like a landscape view, we get also more information about the surroundings. All right. Next thing.
Another question.
Yeah.
What does it depend on how fast it's working? Like if
Yeah.
I'm using,
So the biggest impact is the steps. The more steps you have, the longer it takes to generate. But also later on, once we start adding things like control and the IP adapter in order to copy styles or the composition, this will also have an impact on how long it takes to generate. Usually with the laptops that we have, it's also a restriction in VRAM. So if you don't have a lot of VRAM, let's say you have 4 gigabytes or 6 gigabytes, you use 2 control nets, 1 IP adapter, a text prompt, and something else on top of this. The VRAM fills up, and then it always needs to calculate a bit, fill it up again, move it, blah, 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 blah. So it bottlenecks it, and then it takes longer.
either it's on the stability matrix.
Yes, stability matrix is also working locally. Just if you use something like Think Diffusion or Run Pods, where you have like a cloud GPU and you rent, I don't know, what makes sense? I don't know, H100, and then you have, I don't know how much VRAM they have 60 gigabytes at least. Now then probably you won't have the bottleneck of VRAM, and it should be way faster. And then also the image size itself negatively impacts the speed. Now if I generate an image with 128 by 128 pixels, this will be very, very fast with 20 steps. So now it's done. However, when I generate an image with 1024 by 1024, it should be, I don't know how many times as larger it is. It's just slower. Okay. For the next important setting that we have from the K-sampler, and then we've covered basically everything that is relevant, we have the denoise. And the denoise is interesting for 2 things. On one side, for in-painting, that's when you have an image, and then you specify an area that you want to change, and it will decide how much we change this area, or if we use an image as an input just overall. So instead of using the empty latent image, now where we start with nothing, we can now create new components and take a starting point, which can be, for example, an old rendering that you have that you want to make a bit prettier, or you want to upscale it. Then we can load an image. How we do this is that we need to first create a new component, which is called load image. So we double tap somewhere in the canvas, and then we type in load image. And it gives us this preview here, and we want the first one. So this is our new component. Here you can click on upload, and then we can choose some different image. Yeah, let's take this one. However, now there is a problem. Our image is pixels, but we want a latent image. So first we need to encode it. This means that we can either double click and type in VAE encode and use this component here. Or the other way, and it's a bit faster, is if you left click on the output and you release it, it gives you the most the highest probability options for the next component. No, so in our case, we want the VAE encode, and it gives us the same thing.
What does VAE mean? What does it stand for? What does it mean?
Honestly, I forgot the meaning.
No, it's fine. It's fine.
Yeah. Good question. I should know, but and the things you can. So what I do know is that you can also use different VAEs, and different models have different ways of encoding and decoding the images. So there are also some VAEs that then can stylize your image itself. So they can get like an analog feeling to it, or yeah, exactly. But I should know. Okay. Anyways, so our VAE encode has one input where it needs the VAE itself, and we can get this from the model. So we just connect it, and then we connect it to the latent. Now we have the latent output, and this goes into the latent input from our K-sampler. Okay. Have you all managed to upload an image? Yeah? Great. If I should be a bit slower or repeat a step, then always just let me know. All right. And here, if we just let's reduce the denoise a bit. Let's put it to 0.7 now, so that we can see it, how it works. So if we queue this up, for some people now there might be an issue. And oh, that's way too high. No, let's choose a denoise of like 0.3. And then we can figure out what the denoise does. Just now use a denoise of 0.3. This way it should stay a bit closer to original image. All right. So maybe for some people now it's very slow. This has to do with the input size of your original image. Because if your image is like a 4K rendering, that means that you have now a shit ton of pixels that you need to change. And also we have to make it smaller. And the way that we do it is that we use the upscale component in order to downscale it. So we can just double click. Yeah, there's no downscale component. Yeah, so you type in upscale image, or upscale by, if you know exactly what size you have. Upscale by is useful if you actually upscale something, and then you can just type in twice, for example, and it takes whatever image size you specified earlier and doubles it. But right now we just use the upscale image, and we wire in our image into the input, and the output goes into our VAE encode. We can also preview it if you want to, in between. So we can also take, and that's always helpful. So to just get a bit more information about what is actually happening, we can also again drag the image output from the upscale image, release, and then add a preview image here. So now if we generate, it gives us the preview, no? And we can see, okay, it cropped the image, and then from there it goes into the K-sampler. And now it should be faster again. A problem that happens is that we use the same, like at least in my case, I use the width 512 and height 512. So now I get a square image. And I actually didn't crop it, it compressed it. If we want to crop, we can also use the crop option here. If we use center now, it just removes the sides. Maybe I want to use the full image with the right aspect ratio, no? So, and I don't know exactly what the aspect ratio is, I forgot. I really don't know. So what I can do is I can just, for example, here I can say, well, I want to keep the height at 512, and the width goes to 0. That means that now it will just figure it out on its own. It knows, okay, my height needs to be 512 pixels. It knows the original aspect ratio, and then it just does the math for you and just downscales to whatever ratio it is. And that's the way I would use it. Just always set one value to 0 and then the other value to whatever you need. Great. And now we are able to generate images based on our input image. And this is where you can now start to play a bit with the denoise. So let's generate, I don't know, 4 images. Denoise of 0, denoise of 25, 50, and 75, for example, or 1. Let's make 5 images. And then some people know how to read, other people can find it out in a more visual way. But both will generate these 4 or 5 images now, and then we can see the results.
And if we change the batch, can we also change those settings? So we want like different settings for each picture in the batch?
Yes, and I need a different component.
Oh.
I forgot which extension it is. Yeah, no, yes, you can do that. You can also, there's one component. You can maybe do it next time. That creates a matrix where you can have 2 or 3 variables that you change, and then it will generate all of the images interpolating these variables. Will give you a big grid. Yeah, exactly. But usually the batch node is used in order to just generate, let's say, 4 options, for example. Use the same prompt, and the batch node then will automatically change the seed of the images, and then you just get like 4 preview images. Yeah. I think what is more useful, and we can cover it next time, is that you can also specify a folder, and then it just picks all of the images within a folder, and then runs them through the workflow, which can be very helpful, for example, if you work with masks. Now you have, I don't know, you have 50 images of architectural photography, and there are people walking through your image, and it automatically segments out all the people, removes them, and places them again in the folder. So you can automate a lot of stuff. But we'll do this, I think, next time. Also, ideally use an interesting prompt. My prompt doesn't make a lot of sense, so now my chair is turning into a skyscraper.
But in this case, the denoise is telling the AI how creative it can be with the
So,
image.
Okay, I think now maybe you all had a bit of time to experiment with the denoise settings. Who managed to generate, let's say, 4 images? Okay, what were your findings?
They got more and more far away from my original photo, the higher value.
Yeah, exactly. So basically, what you already said as well, the denoise value is more or less the percentage of how much it changes the input image. And let's say the more different your prompt is from your original image, also the earlier you will see that it stops making sense, no? Because so this is this here is a DNOISE of 0.3 and this is 0.5. So what happens is basically, usually we start with the random noise, no, and then it just, if you have a DNOISE at 1, it will change all of the pixels the whole time in order to generate something. Here, instead of starting with a random noise, we have replaced the noise with an input image itself. So we already have some pixels that are set in place, and it starts to change them. So this means that if we have a low denoise, it will only change a tiny bit the pixels that we have. No, and then the modification that does the original image won't be that large. This workflow in itself is not the greatest if we want to use it, for example, in order to render an image, like properly render it. And for example, we create like a very basic, some basic volumes in Rhino, and then we want to make an amazing architecture project out of it. This won't work with this workflow because we don't have a lot of control, you know, it just randomly in a way changes our pixel values. However, this can be great if we want to upscale an image. So if we want to increase the size of an image, let's say by 2, from 1024 to 2K, what we can do is that we can use our upscale component. I'm going to use the smaller one in a second. Okay, so my input right now is 512 by whatever, and then I can just use my upscale by component. Let's move this here. So I want to have an image twice the size, and this goes into my VAE encode, and then I can use a very low denoise of maybe like 0.2, 0.3. And now what it does is that you won't have this component probably. I'm just going to use it now for demonstration purposes. There's the image compare node where we can then compare our input and our output. Take some seconds. Okay. Here you can see this is my original input. It's very, very pixelated. No, and when I'm upscaling it, I'm just doubling more or less the amount of pixels that my image had. Some algorithms are better at upscaling, some are worse. No, some just double it, some create the average of the next pixel and like in between the pixels basically. Nonetheless, it will be a bit blurry. But if we use the upscale component and a K-sampler with a low denoise, it will start to add a tiny bit of additional information. No, because it has original image, it has a prompt, and then if it just goes over it once or twice, it knows, okay, this might be a pen, so my pens get a bit more pen-like with the denoise, or textures are a bit improved, no? It knows, for example, that this is a keyboard. This is my just upscale picture, and this is an upscale picture with the K-sampler at 0.3. Yeah, so I think this is a very helpful, simple way of upscaling images. However, later on we will also have better ways of doing it once we go into the control net. All right. So yeah, if you want to do this, you load the image. And then you use the upscale image by or the upscale image to either dial in exactly the values that you want, or you just upscale it by 2 or by 0.5, or in whichever direction you want to go. You go into the VAE encode so that our model understands what it's doing because it's in the right image space. K-sampler, we decode it, and then we can check out the output. All right. let's do the next one.
So were we able to maximize the window of the compiler?
Yeah, this works with all the nodes. If you go close to them to the corner, your mouse changes to the scale thingy, and then you can just make them larger. Okay. I think the next thing, or the last thing that we can cover in this workflow is the in-painting part. The in-painting part with the SDXL models is also a bit of a gamble, but we will do it. If you use Flux, which we can cover at some other point, or I can show it to you so that you have to work with it on the cloud and your laptop is good enough. There you can make amazing in-paintings where you have the input image, you take a product photo of a couch or whatever, and then it will more or less perfectly place it in your image itself. Here, the results are a bit more random, but nonetheless, let's go over it. What we will do is we need a different VAE encode component. So we can remove the one that we have, we just delete it. And then we double click. And then we type in paint model conditioning, which is this component here, in paint model conditioning. This needs a lot of inputs and a lot of outputs. So, what are we doing? First, it wants a positive and a negative prompt. Because what the in-paint conditioning more or less does is it adds the image itself to the prompt. So we have our text prompt with the addition of an image, more or less. So this means after we wrote in the text and code what we want to see in the image, we could wire it into the positive prompt. And the negative prompt goes into the negative input. You can also move everything a little bit more easier to understand. Also, we have our positive text encode, it goes into the positive in-paint conditioning, and the negative one goes into the negative one. Then again, we need the VAE. So we also drag the VAE into the input. We need pixels, so this is our image. In my case, this is the upscaled image to 512, because I want to work with a small image. It goes into the pixels. And then the mask. And so for the mask, there are two things we can do. Well, there's a lot of things we can do, but for now, you either use the image itself, and there's a mask editor that we will use now. So we just wire in the mask output from our load image into the mask input, or we can also load a mask from Photoshop, or we can generate a mask with other components, and these would also go here. You know? For example, the in-painting workflow where we remove people from an image, then this would mean we have the load image, we have some nodes that do the segmentation for us and generate a mask, and then this newly generated mask goes into the in-painting. No? But what we will do is just, we can right-click on our image, and at the bottom, there's the Open in Mask Editor option. It opens this window, and maybe the butterfly is a bit too much. Let's remove it. And I'm also going to remove the plant here. You have all of these tools. You can decide the thickness of your brush. That might be a bit too much. You get smaller. You can reduce the opacity. Yeah, I think these options here are easy to understand, no? That's what you would have maybe in Procreate or Photoshop. And then afterwards, we click Save. And now here we can see our mask. My mask has a problem here. I will fix it. Again, I open the mask editor. This should be fine. I save it. And all of the white space in my image is the new mask. And here, this is where I'm going to remove stuff. Yeah. So if you work in Photoshop, You can also use black and white and gradients, yeah, like shades of gray. Everything which is black stays the same. Everything which is white will be changed. And then we can later also cover things where we use a blur in order to create a smooth transition between the area that we in-paint and yeah, the non-in-painted area. But black and white works for us.
So again, the white one is the one that makes you change things?
Yes,
Okay.
exactly. Let's see.
But what if the picture has a lot of white?
No, that's fine. It's, like if your image contains white color, it's different than the mask. This is just the way it's previewed here. It just adds additional white on it so that we can see it visually, but it's a different image. That is just on top of the image that you see. So your image, the white in your image will not impact the painting, except if you use it for that purpose. There's a different node that is called converts image to mask, and then you can say, okay, all of my white should be used for the painting, for example. Yeah. Also, in order to visualize it, we can use a component convert image to mask, basically, or no, mask to image. One second. Convert mask to image, and then we can also wire our mask into this, and then use a preview, image preview here. And then if I generate something, 1 second. Okay, here you would see now this is the mask that I have, and it did not take into consideration my windows or something like that. Yeah, but to finish the component here, the in-paint model conditioning, what we need is now the positive one goes into our K-sampler, into the, so yeah, the positive one goes to the positive input of our K-sampler, the negative one into the negative input, and the latent, which is the latent image itself, goes into the latent image. And then I can also change my text prompt. So maybe a text prompt is now just a photo of an office with lots of things. I don't know. Not the greatest prompt, but I just want to remove objects, so I know I queue it. My denoising should be at 1 in order to remove everything, because else it will just enhance maybe the whatever you have, no? Let's see, as you can see here, I've got rid of whatever it is. Now it tries to place things there. This is a very bad image. 1 second. Maybe I have to, like, my prompt needs to be different. I'm just gonna, yeah, no prompt at all. Let's see what happens. That's also not great. But yeah, that's a bit also like the problem with SCXL. The in-painting itself is not really amazing. But since we will need it for other functionalities, we're covering it right now. Yeah. Maybe lower denoise could help. Anyways, well, this is at least that's how in-painting works. There are also models trained on in-painting, which perform a bit better. This is also what I would usually use. There's also, like, I think of epic realism of Juggernaut, they also have the specific, sometimes they're called fill models, other times they're called in-painting models, and they are a bit better at like context awareness. That means that whatever it generates blends in better with the final result. Well, all right. Let's jump to the next part, as we only have like half an hour left today. So what we're going to do now is we're going to use a reference image in order to generate things, because we have also the IP adapter and we have to control that. So the IP adapter is something that copies a style or other people's artworks if you want to. So what we can do is we can double click and then we type in apply. Oh no, let's control that. 1 second. Oh no, we just write IP adapter. You can use either IP adapter advanced or the IP adapter the normal one. Shouldn't make too big of a difference for what we want to do now. I'm just going to use the advanced version. Maybe also just stick to the advanced one. So IP adapter advanced gives us this new node here. And the IP adapter is like a modification to the model itself. This is not connected to the clip text encode, but rather it wants the model as an input. And then it's kind of like a fine-tuning in a way that you do based on one image. So it wants first the... do you all have this option or not? Some of you don't? Okay, so that means that you need to install the extension. Okay, so for the people who don't have the IP adapter right now, you need to go into the manager, and this is for everyone. This is how you install usually the extensions. You click on Custom Node Manager, and here you get a list of all the available extensions for CompUI, or let's say for 90% of the extensions. And then in the search bar, like you can either by filter, you see what you have installed, no? Filter, installed, and you see, okay, these are the extensions that I use. Or you click on all, and then here we type in IP adapter, and then the first option, ID number 95, here, this is the one that you want to install. So if you did not have the option, because the node did not show up, then you just need to click install, and then it should install it for you. So click install, then wait, and then at the bottom it will tell you restart in like bright red color. You click restart, and then it should work. How many of you have it installed? Okay. How long does it take to install? Yeah? Okay, did it already install for someone? Right now? Did you try to?
It's slowly.
Yeah, that's fine. Yeah, you have to restart it. Shouldn't take too long. Okay.
It also says that it's already installed.
Ah, okay, that's good.
And then I said update, and it says I need to restart.
Okay. But then it should be fine, no? If it's already installed. Yeah, question?
How do we save our thing?
Yeah.
When I go to save it, does it as a web page?
Yeah, so when you just click save here, it should pop up in workflows. On the left, there's a folder, and then I installed it today again. So there's nothing in here, but if you press save, you give the name, now it pops up here. And if I randomly remove a lot of things, and now I open a new one, I can just drag and drop, I can just click on it and it opens up the same thing. You can drag and drop workflows. So later on I can also share them with you, no? And then you can just say, okay, I want my site transfer workflow. And I just drag and drop it in here. And then like a grasshopper script, no, it gives you everything. And what's also cool with CompuUI is that you can generate an image, and then you give the image to another person, and then if this person just drag and drops the image to CompuUI, it reads the workflow from the image. And then you get all the settings that have been used when it's generated. So if you don't want people to copy your image, remove the metadata from I think Photoshop can do it, or there's also just like online tools that remove the metadata. Yeah. Exactly. Question?
Like in the entire workflow, if I have like just 3-4 nodes to run, I don't want the entire thing. Is there any way to do that?
No, I think then you like either remove everything, or you share the workflow and other people can read it. Yeah. Okay. Did it work with the installation of the IP adapter so far? Who installed it now? Or who's still waiting for the installation? Okay, then I just continue with it. See? I share the scripts with you anyways. Okay. So in case you're not able now to follow up, it's fine. I share the scripts, you can just drag and drop them in. So for the IP adapter, what we want to do is it needs a couple of inputs. It needs the model, so we take the model output from the load checkpoint, goes with the input, because that's what we want to modify in a way. And then we need an IP adapter. So here we can just hold it, release it, and then use the IP adapter model loader. Or we can double click, type in IP adapter model loader, it's the first option, this one. And ideally now, here it should state something like IP adapter plus SDXL. That means that you dragged it into the right folder. All right. The second thing that we will need is clip vision. So at the bottom, there's a clip vision input. Again, drag and release. And then it says clip vision loader. Or we double click and type in load clip vision. It's clip vision, it's not clip. It's two different things. Here, just the clip vision loader. This one. And there you should also have now the option, I think in your case it's called model.ae or something like that.
Yeah,
this is the part that I said it will create a folder where you have to drag and drop on the last model. Yeah, exactly. So after you installed IP adapter plus in your model folder, if you're in Stability Matrix, just open Stability Matrix and go to Model Manager or the Checkpoint Manager. Else open folder and then open models. And then there should be one folder which is called Clip Vision. No, it's not Clip, it's Clip Vision. And then in Clip Vision, that's where you have the file, I think in your case it's called model.ae or something like that. Or .save tensor. Yeah, exactly. Yeah, and it's actually this file, it's clip.h. I don't know why this just renamed it. You don't have to rename it, but it gave it the wrong name when downloading. In Stability Matrix, you open the Checkpoint Manager, and then there should be a folder called Clip Vision. No? Okay, then we can create.
It's called invoke clip vision.
No, that's a different one.
Ah, okay.
Yeah.
Actually, I have the folder, but I don't understand.
Then you need to download the save tensor. So if you're in Stability Matrix, you can click on which one?
I do it through the local.
Okay. Then you need to download. I think it's the main, the link. And else you can get it from Hugging Face. It's called clip.h. Hugging Face. 1 second.
If we don't have clip vision in a folder,
If you are in Stability Matrix,
Yes.
you can follow the docs. So here, starting from here, you will click onto Model Browser. Then at the top, you can click on syntax or Hugging Face. You click on Hugging Face. You scroll down till you. No, actually, it's specified. Oh yeah, okay, yeah, exactly. So then there's one that says Clip Vision Diffusers, and it's the first option that is called IP adapted encoder. Even though you're using STXL, you just download the normal version, not the STXL version. That's important.
Vision diffusers.
Yeah, it's
Okay.
download the one that is called IP adapter encoder. The
I
normal
have
one.
it already.
I have it too.
And it's okay. Then you downloaded it.
Yeah.
But it's not showing up in instability in CompuI.
Instability matrix.
It's, I don't have a clip vision folder.
You
So here it says the basically have and then manager I don't have yeah, it doesn't show me this one.
But like I did do it. I did. Or I did.
So this is also the name of the one here.
I'm so sorry.
Do you have this one?
Yeah, it's the same voice. Yeah, it's just the name is different. I think for all of us it's
okay, just the name is different.
no, I have it as IP adapter as the image encoder. This is the name.
IP adapter.
No, wait,
the same.
But okay, so is it showing up? It just has a different name. Does it have a different name? But you have something in there?
Clip vision or?
No position.
I don't know.
Is it called IP adapter image encoder? Blah blah blah.
IP adapter.
Or do you have nothing
IP
at all in
adapter.
there?
When you go to CompuI, you check the interface.
But I have that one.
When you go to the
Yeah,
component,
both are in
so there's some
Vision.
What's that? So what do you
Vision loader. IP adapter
Yeah,
is
there
the
you go.
image. Oh, okay.
so I think
Okay. So apparently, so if there is something, even though it has a different name, it should be fine. Apparently, it's called IP adapter vision encoder or something like that, or encoder or something. Yeah, that's fine. It just has a different name. Yeah. Good. Yes. All right. So. So we have Clip Vision, we have the Clip Vision loader, and it says whatever it says here. Okay? For some it says Clip Vid H, for others it says model safe tensor, and then for others it says IP adapter encoder or whatever. As long as there is something here to select, it will work. Probably. We'll check it out now. Okay, and then the last thing that we need is the reference image that we want to copy, or that we want to use for inspiration. So we can just double click, we can load an image here. Let's select something, I don't know. I'm going to select whatever image it is, and then I'm going to wire in the image here. Apparently, you can also use negative images. I have never used this feature. You can try it out. Maybe it offers great results, but yeah, I don't know what to use it for. Anyways, so we have our model input, we have our IP adapter input, we have our image input, and we have clip vision. The mask is something that we can use later on in a different workflow, where we can also say, okay, in this specific area, take that image as a reference. But we don't use it now. Last thing that we have to do is we have the output of our model, and this now goes into the K-sampler. So our whole script, if we want to, could look like this. We have our load checkpoint, we have our clip text encode positive and negative. The positive one could go into the positive one, negative into the negative one, and then we can have like an empty latent, just an empty latent image, or we use an image that we have loaded earlier together with VAE encode. Gives us the same result. Since I don't use a different image as an input, I use the latent noise. My denoise is always 1, else I get shitty results. And then if I now generate something, ideally I adjust my prompt also to the reference image, so I would say an exterior photo of a restaurant with waterfall, for example. Right, if I queue this up now, we can see clip vision is loading, and ideally you don't get any errors with this right now. It copies our image with the IP adapter, sends everything to my K-sampler. And here now I should get like a very similar image to the one that I referenced. Also, on the right you see my reference image, on the left you see my generated image, and then that's where I can now start playing a bit with my values. No? So maybe I only want to copy the style, but I don't want to copy the composition. So I can click on weight type, and I get a lot of options, and I usually ignore all of them except for style transfer and composition. So we can use, for example, now only style transfer. We can generate something. And probably I should get the same colors and maybe objects, but in a different configuration. No? So my reference image on the right. Now here this is only copying the style on the left. Or I only copy the composition. You can also chain them together. So we can have one IP adapter which copies the composition, one IP adapter that copies the style, or two that copy a style and one that does the composition. However, also here, the way that we're copying the composition is not as precise as what we will look into now with the control net. Because the control net itself is something that's only made for composition. So and here, okay, so for example, now you can see that my colors changed, but I said like a waterfall and the building to the right. Great. Does this work for all of you, the IP adapter? Yeah, but who managed to generate an image with the IP adapter? Okay. Great. The rest of you is trying and it's not working, or more just like something back in? Ah, okay. Got it. Then I think what I will also do now is I'm going to show you now the control net. We only have 15 minutes left. And then next time we will look a bit deeper into the whole thing and how to use them now with a bit more time and everyone having everything installed on Friday. But now you sort of get an idea of what we can do basically. So this is our IP adapter. There's a neat trick for CompUI, and that's that a lot of times we have to repeat the same configuration of nodes. So instead of every time creating everything from scratch, we can also group them together and then create these clusters that we can save and then just paste them. No? For example, I have my IP adapter cluster that I can just quickly paste, and then I have my IP adapter loader, vision loader, load image, blah, blah, blah. And the way that this works is that we can first select all of our nodes. This. Now you hold Shift, click on 1, 2, 3. And then if I press Control G, I can create a group. So this group is maybe my IP adapter group. Okay, I think I created two groups on top of each other. Anyway, so this is my IP adapter group. I can place them wherever I want. And then these groups are very helpful because I can basically drag in all of the nodes at once. Or I can also right-click on the group and then choose Select Nodes. And now all of my nodes are highlighted. If I want to delete a lot, for example. Or I can select all nodes and then bypass them, which now means that they are not being calculated. I can also set them to active again. And the other thing is that I can, again, right-click on the group, select nodes. I select the node, the group node as well, so everything is highlighted. And then I right-click on it again, and it should say select. It says save selected as template. I can give it a name. So I would name it IP adapter. In my case 2, because I already have it. I confirm it. And now if I go somewhere else on the canvas froze. Okay. Okay, I think my computer froze. 1 second. Sorry. Not that stable. But basically for the people who saved the template, you can now right-click, select template, and then paste it. Does it work? Or, yeah? Great. Okay, I can also share my templates with you. I can also upload them to the drive, and then next time I show you how to use them, so that we can easily build workflows. No? Yeah, my workflow is gone. But that's fine because I have my template. And also, this is the standard workflow. Now I can just right-click, no templates. I can choose my IP adapter template. Place it here. No template, IP adapter. So I have it here, and then I just wire in the model into my IP adapter. And back it to the K-sampler, and everything is working again. And then the other thing that we can do is the control net. The control net is the one that we will mostly use for all of these renderings. So what the control net does is that it takes, for example, a depth image or like a canny edge image that we can generate from another input image. No, it's just like a depth estimation, for example. And then it uses this in order to guide the diffusion process. So what this means is I can double-click and then apply control net. If you don't have this one, manager, custom nodes, and this one is called control net auxiliary preprocessors. So then you update this one if you don't have it. I will add it to the email. Basically, it gives us this control net, and the control net is not part of the model; it's part of the clip text import, basically, or of the conditioning. So again, it needs like the positive input and negative input of our prompt. It takes the control net itself. So here we have the control net loader. And in between, we have the set union control net type. Because we're using like a newer control net that can work with a lot of different inputs. It can use a depth input, it can use an open pose input, if you have a character, it can use any edge input, a normal map, whatever it is. But all the control net types, you have to specify, like, use one controller for one specific use case. And then we have our image. And then, for example, here in my image, I can again load my chair. And I have to pre-process it because this image here is, doesn't contain the depth information. Maybe I just rush through it because we don't have time. You see what it does, and next time you do it step by step. So I load my image, and then I can convert it, for example, using depth anything that you might have already used for image analysis or something like that. And what this one does is that it automatically estimates which parts of my image, I'm just going to bypass this, which parts of my image are in the front and which ones are in the back. So if I load this, first time it always loads. Ah, it's a wrong one. Shit. No. It's trying to download a model here at IAC. Not sure if it's faster if I restart it. Yeah.
So I have another annoying question.
Mm-hmm. Yeah,
if we have the control net model and our control net name is undefined, so it seems like there's no model there.
Yeah, that means that it's either in the wrong folder or you didn't download it.
Okay, but should I be able, because I downloaded it as an extension that you asked for, so do we need something like additional to that, or?
No, yeah, you need to, there's one model that is called PyTorch dot whatever. This one here, that diffusion PyTorch model for Max. And this one needs to be in the control net folder. So models, control net, and then it should be there.
What does the control net do?
What it does?
Yeah.
Yeah, it's, here I show you. So, for example, with the preprocessor here, with depth anything, it automatically estimates which parts of our image are in the front and which ones are in the back by creating this depth map using black, white, and everything in between, radians. And then we use this image in order to guide the diffusion. So then also our image will have the same composition. So if I wire this in now into my K-sampler, I'm going to ignore this part. Okay, ideally my text prompt should also be related to it. I have to change my prompt. Office space with concrete furniture. Okay, somewhere in Berlin. Let's see. So if I compare this image here with my original image, as you can see now, it always sticks to this. You always use this here as a reference. Now, and whatever I generate, it will always maintain the same composition. So here I can now start to play around with my text, for example. Here I prompted for like a concrete furniture office. So maybe my office is actually made out of pink PVC. And again, it maintains exactly the same composition that it extracted with the preprocessor. And just like retextures it. And this is ideal to make a bit more complex workflows. Now we can use, for example, we have our input image, and then I want to get the right aspect ratio. So now here I would upscale it, upscale image, and let's keep it more or less the same. Just copy the height again. Okay, we remove the latent one. This one needs to be encoded, no, because we need it in latent space, so VAE encode, pixels, and we need the VAE from the load checkpoint manager. This goes into the K sampler, so now we're not using the 1:1 aspect ratio, but the original aspect ratio. Let's queue this up. And then in the meantime, I can also use the IP adapter, where I then copy a different style. So in my IP adapter, I would, for example, say, well, we can just copy the style of the waterfall. It doesn't really make too much sense until you find a reference which is somehow related to your original image. But let's see what it does. Maybe if we lower the weight a bit, it should only transfer the colors. Let's test this. Pink office space, pink VC, glass windows, and water features, whatever. Queue this. And now we take the composition from our lower image together with the style of the IP adapter, and both of them feed into the K sampler, where we transfer the style from one and apply it to the composition of the other. So let's see what it does. Okay, well, this is my result. Maybe I need to increase a bit the impact of the IP adapter. So here I can maybe increase this to 0.5 or 0.75.
What will it do?
This is the weight of the impact of the IP adapter.
So how close it's gonna
Exactly. So, but for example, if the weight is, I'm gonna exaggerate, 3, maybe that's too much, then it will be very ugly. But if it's 2, then probably it will be very close to a waterfall and outdoor space, and we lose the office space, even though it will maintain the composition. And we'll see now what it does. Probably there won't be a chair anymore. So this is where we have to find the balance between our prompt and the IP adapter. And then you can also, they control it as well. I mean, this is a horrible image. Probably if we reduce a bit the weight here, 0.6 maybe, that would work. And then I give you with an image of a different office that fits somehow the style that we want, then we can get those results. And this is also the workflow that you see in a lot of these programs now, that and these web services that create the architectural renderings out of your Rhino input. No? Also the depth map that we get here, we can get them from Rhino directly. There's a Rhino command, show zbuffer, which creates this black and white map for you. And then just by copy pasting it, basically, we can directly wire it into the control net. And then in Rhino we can just create the composition of the image. We work with maskings, for example, and then we give it a reference of the architectural style that we want. And then together with those two inputs, we generate the image, and more or less then like renders out in like high detail what he wants to achieve.
I have a small question.
Sure.
Again. And when we're working with like architecture and urbanistic prompts, is there a way to have some more control over the how straight are the edges? Because this is something like quite important for those kind of drawings, right?
Exactly. So there are different. The control net offers you different inputs. For example, right now we're using the depth map as an input, but there's also a different one which is called, for example, cunning edges, or there's the MLSD. Cunning edges. Well, that's preview then. That's probably the easiest way of explaining it. Preview, then we're going to bypass this one so it doesn't calculate. And if I queue these up now, so the cunning edges one basically finds all the edges, also if they are curves. It's wherever you have a bigger contrast in pixels, you know, and there's some pixels in a placed like in a straight line or curved line, and then other pixels right next to it with very different values, then it will create the edge, more or less. And instead the MLSD only looks for straight edges. So maybe you have an interior room and it's a bit cluttered, so you only want to extract the straight features out of it, then MLSD is the way to go. Or you want to retain as much detail as possible, then you can use the Canny Edge one. And then you can connect them. So this means that I have one control net that I use to get with the black and white image, but maybe I'm still losing too many details, for example, because I have a plan and I want to maintain some straight lines. Then I can just create a second control net, and then my first control net goes into the second one. And then I connect again the set union type here again. I can reuse the same one. And from here I get my canny edges instead of the depth. And it needs VAE as well, so I take my VAE from the model to the control net, and then unbypass this. Now the second control net goes into my K-sampler. Let's see what it does. It should basically probably maintain also like the plan, for example, and some details from the table, I assume. Yeah, I think also when you generate characters, for example, or people, there it can be helpful to have, for example, the depth control net, but then also open pose. And open pose then figures out exactly which way are you looking, and where the eyes, where's the mouth, where's where the limbs. Yeah, and also here, for example, now we maintain also the plant, the butterfly. It's just, yeah, we got more of the original image back into the new one. And this same thing also works with the IP adapter. Now, if I want a second IP adapter, I can also just add a second one, add no template, IP adapter here, and I wire the model into the input, and then from here it goes through it. So that's how you can, yeah, have multiple reference images, multiple control nets. You can also specify for how long they run. So I could say, okay, I want the composition of the depth happening in the first half of the image generation. For example, here start percentage at 0 and percentage at 0.5. And then afterwards, I want to add the details of the second control net. And then here I start at 0.5 and it ends at 1. So 50% of the image is generated based on depth, and then 50% is based on the edges. This doesn't make too much sense right now, but what I do a lot is if I use the control net with the depth, I only run it, especially if you work with maskings and no details, I only run it, for example, for the first 60% of the image, and then I deactivate it. Because then it has the possibility to also invent a bit more details that go a bit out of the facade or into the facade. And else, if I have this plain surface, it wouldn't generate a window because it knows now this needs to be flat. So yeah, but we can look into this next time with a little more detail.
I have a question. When you start working with Rhino and then you want to play it with the massing, is there a way to have Rhino and UI connected, or you have to export the image?
I wrote a plugin, but I'm not sure if it's still working. I can check and then I can give it to you. Then there is a second node that creates. It's not really a live link because you can just specify a window on your desk on your screen, and then whatever is within this window then is live feeded to Conf UI. But this means that you just have to like open the window and drag it above the Rhino instance, and you need both things open at the same time. I haven't seen a good plugin that does it. Invite it. Yeah. Does this make sense for all of you, more or less, what the controlnet does, what the IP adapter does, so that next time we can start playing with these things and get deeper into them? Nice.
Just another question. If we save the workflow, because when we're working in our like local host server, if we save it like just do it from an NAS or whatever, will it be there still if we close the window and reinitialize it with our stability metrics?
So look, even if you don't, this one's not saved right now.
Yeah.
If I just close it and I open it, and this also is the same for stability matrix, it saves it. So always like the last workflow that you have used is saved.
Okay.
But this is not ideal. Like ideally, you click on save, and then it should be stored. So you don't have to worry about that. However, you have to save them. Sorry, you can always export them. And then you get them as a JSON file, and this is also a JSON file you can share with other people. So if you click on edit and on workflow, then it also gives us the option to export or export as API. For us, we just use the export function now. But for example, if we have an API, then this would save it in the format so that it becomes the package that we send to the server. But yeah, so if you export it, it just saves it as a JSON in your download folder. If you get a workflow from another person, and this person has installed some extensions that you don't have, it will also notify you. And then if you click on Manager, you can click on Install Missing Custom Nodes, and it will look through the workflow that you have imported and tell you everything that is missing. Not the models, though. It basically tells you only which extensions are missing, and then models you might need to download them manually from somewhere else, or in Stability Matrix you find them. Yeah. More questions? Okay. So for next time, I have to send you a list of the extensions that we need, no, in the email. I will send you again which models exactly you need, in case someone's missing a model. I will send you the scripts that we will use, so that you can just drag and drop them in. And what else do I have to send you? Is there something?
You also upload the script of today?
Yeah. Yeah, I can upload the script of today.
For the models, could you say which folders to put them in? Or
Yes. Yeah. I will also, do that. Okay. And maybe I can also share you like a YouTube tutorial for like the very basic, like everything that we have covered today, so that you can watch it at home. Okay, great, that's it. See you next week. No, see you Friday. Yeah.
IP adapter, it's include click vision.
Okay.